ABCD with the angle ADC and is equal with the angle ECD is equal with 15 degree. Prove triangle ABE is equilateral triangle. So we want to prove this triangle here. ABE is equilateral triangle. And so just let me take those information what we have here. So this here, so this angle here, angle C, EDC, EDC, this angle is a 15 degree, and this angle here, ECD, ECD is a 15 degree. That's what we know. And now, how we can prove it? Because this side, we already know this is a square. This side and this side of this triangle, AED and the BEC are the same side. And because those two angles are equal, the sides here are equal, so those two sides are equal of these triangles. And what do we know else? Here this is a right angle, but here is a 15, and everything is 19, plus a 17, 75 this angle, 75 plus 15 is a 90 degree. Same thing happened here. So this here is a 75 degree. And now, what do we have here? We know this triangle and this triangle are equal. And as what do we know? We know the other thing, because of these two triangles are congruent one with another, it means all the parts of this congruent triangle are congruent. So, and this part here is congruent. So that's what we know right now. And for us is important now to see, so this one is A. Let's say this is a whole distance is A. In a half is A over 2. And if I divide in half, here is A over 2. And this is the midpoint here. It's midpoint because ED, DE, and EC or CE are equal. And because those are equal, here has to be the midpoint, okay, of these two triangles. This is the midpoint. And what we do know, what we need to know, is this equal with the A? So this distance here, EB or EA, those are congruent, doesn't matter which one, we can prove it. Are these distances equal with A? Or are all the sides AB, BE and EA are congruent? If we are taking now, making here a straight line, it's not very straight here how I did it, but imagine this is a straight line. Here is 90 degree, here 90 degree. If here is 90, this here is a 15 degree. Okay, so this is a straight line. And now this part here is A over 2. Okay, but from here, from this position, let's say position F. I don't have any F, okay? So this is a point F. From the point F to B, we don't know exactly what it is. It's not A, it's less than A. But let's say here is a 60 degree. Okay, this is a 30 degree. And a 60, 30 degree, 30 and a 60 and a 90 degree. We know the sides are A over 2 are A, and is a square root of 3 times A. Those are the sides. And this side here is a square, from B to F is a cubic root of A. And this side is A over 2, and this side here is hypotenuse is A. And because this is A and the other side is A, okay, so 30, 60, 90 degree, so this is A. And if here is 30, this is a 60 degree. And this here is a 60 degree. And if I'm going here to make a very straight line, here is a 60 degree, right? And here is a 15. What does it mean? So this angle here, this angle is going to be 75 degree. And this angle here, 15 plus 60 is 75 degree. In this case, the triangle A, so let me write here, triangle AD, I didn't write here one letter, let me write M is a midpoint. Triangle ADM is congruent with the triangle BFM, and those are isosceles triangle, while the triangle we already proved because all the sides of the triangle ABE are congruent, so the triangle ABE is equilateral triangle. So we already proved here.